Hello friends, continuing with the chapter of current electricity. Today we come to its seventh part as per mind map, that is measurement of EMF. Today's topic is measurement of EMF. Now first term that we are to understand is EMF and PD of a cell. Now what is EMF? The terminal PD of the cell when the cell is in open circuit. I repeat, the terminal PD of the cell when the cell is in open circuit is defined as EMF. It is denoted by the letter E. Now you look at the circuit. When the cell is in open circuit, then current through the circuit is 0. Then the terminal PD is E. 2. PD of the cell, that is potential difference of the cell. The terminal PD of the cell when the cell is in closed circuit. I repeat, the terminal PD of the cell when the cell is in closed circuit, and it is denoted by V. Now look at the circuit. Here key is closed and current I is not 0, means there is definite current flowing through the circuit. In that case, the terminal PD of the cell is potential difference and it is denoted by V. Okay. 3. Relationship between EMF and PD of a cell. Now consider the closed loop A, B, D, C, A. According to Kirchhoff's voltage law, we have voltage equation as minus I into capital R minus I into small r plus E equal to 0, or E is equal to I into capital R plus I into small r, but I into capital R is V according to Ohm's law. Therefore, we can write above equation as E is equal to V plus IR. Let us mark it as equation 1. Now from equation 1, we have V is equal to E minus IR. Let us mark it as equation 2. So this is the relation between EMF and PD of the cell, since E is EMF and V is PD of the cell. So the two are related as V is equal to E minus IR as per equation 2, or as per equation 1 as E is equal to V plus IR. Okay. So this is how EMF and PD are related to each other. Now 4. Internal resistance of the cell. How we determine internal resistance of the cell? Let us see. Now from equation 1, we have internal resistance small r is equal to E minus V by I. Now we replace I by V by R. According to Ohm's law, I is equal to V by R. So therefore, small r can be expressed as E minus V divided by V by R. And when R goes upward in the numerator, then small r becomes equal to external resistance R into E minus V by V. Or we can write internal resistance small r is equal to external resistance R into E by V minus 1. And finally, we have the expression for internal resistance R of the cell is equal to external resistance capital R into E by V minus 1. Now you can see in the circuit diagram, this is the external resistance R and this is the internal resistance of the cell. Thus we have expression for internal resistance of the cell as small r is equal to capital R into E by V minus 1. Okay. Now discussion. First point of discussion is that EMF is more than potential difference. Let us see how it could be. Now read equation 1 as E is equal to V plus IR. this equation shows that E is more than V by an amount I into small r, which is the voltage drop across internal resistance small r of the cell. That is, off-load voltage is more than on-load voltage. Second, a voltmeter can't read EMF because when it is connected across the cell becomes in closed circuit, and it is potential difference now and not EMF. Okay, so when we connect a voltmeter across any circuit, it draws some current from the circuit itself for measurement. So the terminal PD becomes potential difference. It is no longer EMF because some current flows through the voltmeter itself, and the cell becomes in closed circuit when voltmeter draws electric current for its operation. Now third, VI graph. Consider the EMF equation of the cell. V is equal to E minus IR, or V is equal to E plus, within bracket we write minus R into I, and it is of the form Y is equal to C plus MX, which is an equation of a straight line, where minus R here is the slope of VI graph as shown. Consider the EMF equation of the cell. V equal to E minus IR. When I is 0, V is equal to E max, and when I is equal to I max, V is equal to 0. Now internal resistance of the cell R is equal to E minus V by I, and is the negative slope of the graph. Now fifth point, current flowing through the circuit. Consider the closed loop A, B, D, C, A. According to Kirchhoff's voltage law, we have minus IR minus I small r plus E equal to 0. Or we can write E is equal to I into capital R plus I into small r. We take out I common, then we can write E is equal to I into R plus R. Or we can write capital I, the current flowing through the circuit, is equal to E divided by external load resistance capital R plus internal resistance of the cell small r. So let us mark it as equation 1. So this is the expression for current flowing through the circuit. Now discussion part of it. Now when R is 0, when external load resistance R is 0, the current through the circuit is E by R and is maximum. Second, when internal resistance of the cell is 0, then current through the circuit will be I equal to E divided by capital R, that is external load resistance, because in that case E is equal to V. Third, when external load resistance R is equal to source resistance, that is internal resistance of the cell, then power dissipation is maximum, because power transferred from source to load is maximum when source impedance is equal to load impedance. Here source impedance is small r and load impedance is capital R. Since the two are equal, therefore power dissipation is maximum. Now assignment 3.7, question number 1. Why a voltmeter cannot read EMF of a cell? Question number 2. Why EMF of a cell is more than its PD, that is potential difference? Question number 3. A cell of EMF E and internal resistance R is connected across a variable external resistance R. Plot graph to show variation of number 1 E with R and number 2 terminal PD with R. Question number 4. A cell of EMF E and internal resistance R is connected across a variable resistor R. Plot a graph showing variation of terminal voltage V of the cell versus the current I. Using the plot, show how the EMF of the cell and internal resistance can be determined. Okay, thank you so much. Next time we'll take up second part of this topic, that is grouping of cells. Till then, goodbye.